Hello, my name is Steve Burt. I'm the team lead for the Economic and Policy Assessment Group at the Institute for Transportation Research and Education at North Carolina State University. I will be providing a demonstration of the cost tool that we developed as part of NCDOT Research Project 2020-44, with the goal to better estimate the comprehensive costs of rail incidents in North Carolina. The cost tool accompanies a research report, a comprehensive cost of rail incidents in North Carolina. The report documents the methodologies used to appraise the various cost elements that are born from railroad incidents. In addition, the report provides an estimate of railroad costs over the last decade in North Carolina, with a detailed accounting of costs for year 2019. The cost tool that I will be demonstrating was used to estimate the values found in this report. Property damage includes all the costs incurred to railroad rolling stock, tracks, or other infrastructure in the railroad right-of-way. It also includes highway vehicles, infrastructure, or other property that may be impacted by a railroad incident. The Federal Railroad Administration's Safety Database Records and the American Association of Railroads Component Repair and Replacement Cost Matrix form the basis for property damage estimates. An analysis of FRA records were used to estimate the property damage costs resulting from rail events in North Carolina. Each record contained the estimated property damage that had resulted from a train incident being documented. Observations from 1990 to 2019, documented in FRA Form 6180.54 and 6180.57 were used. And the property damage values were converted to $2020 for a consistent cost basis. It was found that rail property damage incidents in North Carolina have a wide range of costs, from an estimated $3,500 up to $7.8 million per occurrence. Now that you've been briefed on the railroad property damage incidents, let's demonstrate how the cost tool works. The tool offers multiple ways to estimate property damage costs resulting from a rail incident. Option A is recommended for instances when property damage costs are unknown. It provides the user with a range of expected values to choose from. Expected values align with the severity of a railroad incident. The user can select a minimum expected value, a maximum expected value, or a property damage value at certain ranges among the railroad incident cost selection tool. A sample of 1,125 records within the FRA safety database were used to develop the range of expected costs for property damage incidents. These records contain reports of property damage costs for North Carolina specific railroad incidents. All costs were adjusted to $2020 using the Bureau of Labor Statistics Consumer Price Index inflation calculator. The range of expected property damage cost values can be viewed to the right and selected from the drop-down menu. The research team recommends using the median selection unless there is a specific reason to choose otherwise. Option B offers another method to input property damage costs from a rail incident. If the user knows what the property damage costs are, they can enter these costs directly in the yellow cell in column F. Values should be entered in $2020. If the incident occurred in the past and the property damage costs are in another dollar year, then use the cost converter calculator to the right. For example, let's say we have a record from the FRA database that we'd like to input into the cost tool. Let's say the incident and damages were recorded in the year 2013. We can use the cost converter to determine what property damage costs were in $2020. Option C offers users the chance to drill down into specific characteristics that may influence property damage costs. This requires completing a more detailed accounting of a railroad incident on the property damage custom worksheet. Users can use the blue button to navigate to the worksheet, or they can navigate there directly from the bottom of the page. There are specific rail incident characteristics that can be directly related to property damage costs. Using the FRA safety database records and linear regression analysis, we found 5 statistically significant variables associated with property damage costs, with R-squared values of 0.78 or higher. These variables included number of train cars releasing hazmat, number of locomotive units derailed, number of loaded freight cars derailed, number of empty freight cars derailed, and number of train cars derailed not specified by type. The regression models we developed enabled us to estimate property damage costs estimated from the occurrence of one of these variables. For example, for every train car releasing hazmat, we can expect that there will be approximately $330,000 in additional costs. We also found that the type of rail incident influences property damage costs. Statistically speaking, we found that the category of incident influences approximately 3% of the overall cost. This information was used to build a cost multiplier that is embedded in the tool. If users know the type of incident involved, this can be input into the tool and it will affect the overall cost being tabulated. Let's do a demonstration. We're going to assume that there was an incident involving one train car releasing hazmat. Additionally, we're going to assume that this is a head-on collision. If the rail incident involves a collision with a highway vehicle, then additional information can be provided. The type of highway user and whether hazmat release occurs from the highway vehicle are variables that also affect property damage costs. To demonstrate, we'll say a truck trailer was struck and that truck also had hazmat materials. You can see how costs are tabulated in the property damage output table. Finally, there is an option to add property damage for specific train parts or components. This option should be used with great caution to avoid double counting. The costs tabulated on this sheet are already accounting for costs associated with damaged components. Thus, it is only recommended to use this option if specific parts or components are damaged, but no other property damage is expected to have occurred in the incident. A good example of this type could be a train braking event that did not result in a collision, but did result in a damaged train component. Often when a train brakes, it imparts strong forces on its couplers. For example, let's assume in this instance that a train coupler knuckle were to be damaged and require replacement as a result of a braking incident. To obtain the cost for this, we can use the American Association of Railroads cost matrix that's embedded in the tool. We can navigate to the cost matrix using the shortcut tab, or we can also navigate there directly at the bottom of the worksheet. Now we're going to look for a coupler knuckle replacement in the list of parts. Highlight the column by clicking at the top of the page. Then hold Control and F That's Control and F for find. Now type in coupler knuckle in the dialog box. Hit find next. We can see that if we were to replace a coupler knuckle with new material, that the total cost would be $150.46. We can use this information for our cost estimate. And navigate back to the custom page and input that value. Now, when we return to the home page, that value has been input into the cost tool.